welcome to Wholesale Telecoms, Staying Ahead in the Post-COVID World, presented by Tejas Networks. My name is Melanie Mingus, Deputy Editor at Capacity Media, and joining us today we have Dr. Kumar Siravajan. Dr. Kumar is the co-founder and Chief Technology Officer at Tejas Networks, where he is responsible for setting the technology and product direction of the company, and he has nearly 3 decades of experience in the field of telecommunications. Dr. Kumar, welcome. Thank you for joining us, and over to you.
Thank you, Melanie. Thank you for the introduction. Thank you, everyone, for joining us today. I hope you're all safe, working from home, presumably. And I assume many of you are wholesale telecoms operators, so pleasure to be addressing you today. So I'll go through several items that may be of interest to you in a post-COVID world. So Melanie, can you just say a quick yes to say I'm audible with all the changes? Thank you, Melanie. So I'll present to you some new solutions that could be useful in a post-COVID world. So let me start by giving you what I'll be going through today. So first, I'll review what's happening in the wholesale market. What are the customer segments that you are likely addressing, and what are the service characteristics? Then I will go through new opportunities being thrown up in mobile backhaul, retail, broadband, enterprise segment as well. And then look at, finally, a few minutes on our products that can help you generate new revenue streams. So the applications that are driving the global wholesale market, and I'm sure that's true for all of you as well, is mobile broadband, data center interconnects. There's a lot of that going on. With COVID, I think home broadband has become a priority for everyone because all of us are working from home, like I'm working from home today. And things like Internet of the Things were always on the anvil, but with COVID, there's a need to accelerate these things because less of us can go to factories and offices. So home broadband and IoT and everything gets accelerated. Later on, I'll show you a specific impact on actual data rates and so on that's going on. So COVID has accelerated work from home. And when people are home, kids, they're doing more gaming. And we're all watching more video. This is being streamed video from my home. So video traffic has understandably grown. And the traffic is expected to keep clocking at a 20% annual growth rate, and will increase 2.5 times from 2019 to 2024. That's like 2 zettabytes to almost 6 zettabytes. And if you didn't know what a zettabyte was, that's 10 to the 21 bytes. So what are the characteristics of wholesale services? So it used to be that in the past, you could just rent dark fiber. Then that wasn't a very lucrative business because you gave it once, it was an IRU, but the amount of bandwidth you can put on the fiber keeps increasing and you are not capturing that value. So many wholesalers have moved to selling some sort of capacity. So you could sell wavelengths, which comes today in 100 gig plus. So it's 100, 200, even 600 gig wavelength in a metro. Or you could sell capacity, TDM capacity in the old days through SDH. Today, TDM capacity is sold through OTN circuits. And for a long time, this was the mainstay of wholesale providers. Today, you could also sell virtual circuits based on packet technology, MPLS TP based, if you're only interested in bandwidth and layer 2 services, or IP MPLS based as well. Typically, the packet services are useful for sub 10 gig kind of bandwidth rates. Beyond that, you'd probably look today at OTN-based services. If you're looking to sell anything more than 100 gig, it would be WDM or wavelengths. Your customers would want quality of service. Availability is very important. It should be all the time available. They want to scale. They start with 10. They want to go to 100 and more. And all other parameters are important. Security is also important. It's becoming even more important today. There's a lot of emphasis globally on security. I'll have something to say about encrypting your traffic at the end of this talk. I'll review three customer segments. These are your customer segments. The first would be mobile operators who need, okay, so for some reason that flipped through. Let me go back. Okay. Okay. I think there is a lag. Okay. Okay. So mobile operators are your first segment. They need reliable, scalable backhaul, and nowadays even fronthaul from cell sites to their packet core or intermediate POPs. The next segment is retail broadband. I know most of you will not be serving your retail broadband customers directly, but what I mean is retail broadband providers, ISPs, could be your customers, and they need to provision increasingly more traffic. In fact, I just upgraded my home broadband connection from 250 GB per month to 1.5 terabytes, simply because I'm here all day doing video conferencing, and I ran out of 250 GB, in April, the first month after COVID. So you need to provision more broadband, connect everyone. People who are making do with wireless connections, 4G connections, are now looking at a dedicated fiber connection. The last segment is large enterprises. In our office, we significantly upgraded the bandwidth because everyone was connecting from home. And that's true for every large enterprise out there. And so everything in all these three segments have changed post-COVID, especially retail broadband and large enterprises. Let's review each of these segments. I'll start with the mobile operator segment. So what's on the anvil in mobile networks is 5G. But more than 5G, it's really, think of 5G as densification. You're adding small cells below the existing 4G cells. And you could add 4G small cells as well. So primarily what's going to happen is none of us is satisfied with the capacity of the mobile network. So we're going to add small cells of both 4G and 5G below the big towers. And all of this will get backhauled by fiber because microwave, which was the other technology, simply isn't good enough to backhaul. There isn't enough capacity. Predominantly, 2G and 3G will continue to be used for voice. Some of us use 4G for data and voice with voice over LTE. And this will continue to be the role of 2G, 3G, primarily for voice, and 4G will be the primary mobile data network. What 5G will be used is to deliver fixed wireless access. So for example, it's not possible to lay a fiber to everyone's home. So 5G is a good way to deliver a high capacity fixed connection up to a gigabit to the home. It will just be coming in from the street. So it is the alternative to fiber to the home. The opportunities with these small cells coming in is to backhaul the traffic from the small cells. And for this technology like XGS-PON is actually quite suitable because the typical capacity from any of these small cells will likely to be like a few gigabits or less, a gigabit or less, about that. So XGS-PON, which is symmetric 10 gig PON, is a very cost-effective technology to backhaul from small cells, whether it's 4G or 5G, especially for 4G. This also means that you reuse your FTTH infrastructure. This is fairly important because small cells will be where your GPON infrastructure is today. So upgrading that to XGS-PON means you could use the same network to backhaul traffic from small cells. The other opportunity is 5G fronthaul. So fronthaul is high capacity. So typical fronthaul rates may be 10 gigabits or even 25 gigabits. And it has to be, the latency constraints are very, very strict in fronthaul. Otherwise, the radio network doesn't work. So OTN is a good technology for fronthaul. It has high capacity and low latency. More than that, you will have multiple mobile operators who have to be fronthauled on the same network. So you need to support the timing domain of each of those operators. And OTN is a very good technology to support multiple timing domains. So we think Fronthaul based on OTN is the right approach. Also 2G, so Fronthaul based on OTN for 5G and small cell backhaul based on XGS-PON, I think are the right technologies to adopt for these new things that are going to happen, which is small cells and 5G. At the same time, you're going to have to increase your backhaul. So 4G traffic is increasing, 5G will increase the traffic even more. And 2G and 3G is not going away. So you'll still need to keep all the 2G. Some countries have done away with 2G, others have done away with 3G and kept 2G. But for most emerging countries, given that so many people have 2G and 3G phones, and you can't really pass a law that you need to upgrade, 2G and 3G will continue to stay. So we will need to have an integrated backhaul network that can carry the legacy traffic, but still scalable to carry the new traffic from 5G. Given the need to have this integration, circuit emulation for the old 2G, 3G traffic, a packet transport-based technology seems the right choice for the first level of mobile backhaul. So what goes to each of the cell sites. At the next level, given the capacity requirements, OTN is probably the right technology. So 2G, 3G base stations based on PDH can be circuit emulated in an integrated transport network. We have examples of this in several of our customers who actually do integrated backhaul for 2G, 3G, and 4G using circuit emulation. We are looking to upgrade all of that to 5G today. 10 gig rings are being upgraded to 100 gig. As I speak, one of our large customers is taking essentially some 700 nodes, which are all 10 gig serving mobile wholesale, serving multiple mobile operators, and the next 2 years upgrading all of them to 100 gig. And OTN is also important. I already talked about the benefits of OTN for latency in the fronthaul, but the same thing also holds true in the backhaul. OTN can give you very reliable performance with low latency, jitter, or wander. The jitter and wander is important because there's 2G, 3G traffic, circuit traffic, and that's voice traffic. So we have to ensure that it's carried with very low jitter and wander. Now, when you, as a wholesale operator, you will be serving multiple mobile operators, and you need to serve them with one network. So you have a shared backhaul network, and we have several customers who are doing this. And when you share this network, today in 4G, practically all of the timing is provided by GPS. But there are several reasons why when you go with small cells, for example, you may not be able to have a GPS antenna. It's too expensive to put a GPS antenna on every cell. So the network will go back to providing timing. Those of you who have been in the industry for long know that networks used to provide timing, even up to CDMA. The clock was provided by the transport network. That sort of went away in 4G, but only for some time. It's going to come back in 5G, and you will need to provide the timing as a service to your mobile network operators through your PTN and OTN backhaul network. Sorry. For some reason, I'm flipping through two slides at once, but let me go back. The other thing that will happen is network slicing. So what's network slicing? Today, your mobile network just carries one kind of traffic. It's broadband traffic, enhanced mobile broadband. That's the only traffic that the mobile network is carrying, because voice itself through VoLTE is simply an application on the broadband network. But going forward, we envisage two more kinds of traffic. MMTC, which is IoT traffic, massive machine-to-machine communication, which is large number of devices having sometimes small low bit rates, but sometimes not so low bit rates, because it could be real-time self-driving or something. So that will require applications like gaming, maybe some medical applications. remote, robotics, or whatever. So, but all of these will require the network to provide a different kind of service, and that has to be end-to-end. So you should not assume that these things are only the mobile operator's problem. They will impact your network as well, because in order to a network slice, which is think of it as a virtual service that serves one of these applications, is end-to-end, and therefore will go through your network, your wholesale transport network as well. And you need to deliver hard QoS guarantees for each slice, and this has to be delivered on demand. So technologies like SDN will come up. Sometimes you prepare for a technology, it never comes, but then there are catalysts. So I think COVID could be a big catalyst for many things, and maybe for this as well. So you can, network slicing may make an appearance, because we're trying to find new ways of doing everything, and that can accelerate what we were preparing for a long time, which is SDN. I'll move on to the retail broadband segment and how you will be serving your retail broadband service provider customers. So COVID in particular has impacted this segment the most. So post-COVID, since the first month after COVID, this is data from Verizon and Colt networks, from Network World. There's a 10x usage in video collaboration. That is very much true. Every day I'm talking to my colleagues on video conferencing, one application or the other. There's a 200% growth in gaming. No wonder, because it's also summer, holidays, nothing to do in the summer. Kids, college kids, everyone's doing this gaming. There's a 40% increase in upload traffic, simply because we are now uploading from homes, uploading data, uploading video. All of that was not there, and of course video traffic has also grown by 40%. So homes will need much more reliable. First of all, every home is now looking for a fiber connectivity or some kind of a fixed connectivity, fixed wireless, as long as it's reliable, non-mobile type of connectivity. Oops, sorry about that. I have okay. So what's happening is that the old GPON technology used to be 2.5 GPON or 1G EPON technology, mostly 2.5 GPON, and that's getting upgraded to 10 gig everywhere. And 10 gig symmetric, if you can do symmetric, why not? So I think 10 gig is almost exclusively likely to be symmetric 10 gig, and that's a good network, a low cost alternative to the traditional approach for serving small businesses and even small home offices and so on. So you can see from this chart that most of the low speed GPON networks, 2.5 gig and 1 gig, are rapidly getting upgraded to 10 gig. So the red is growing and is going to dominate. In this scenario, you need to be able to add new users rapidly. So you may have existing business customers, existing residential customers who already had the foresight to get fiber. But if there's a new customer, for example, a hospital, which for some reason never thought it important to have a high capacity broadband connection, but now they need, because patients can't visit the hospital. So there's all sorts of remote medical services going on. Earlier, it used to be almost impossible to get a doctor to consult remotely. Now it's almost impossible to go see a doctor in person. So when these new customers want to go online, a quick alternative is to set up a fixed wireless connection. If you have licensed spectrum, I think you never used much of that. We know many customers who did that. This is a good way to set up. This is a good time to put that to good use and set up fixed wireless connections very quickly. And once you get the customer on board, you can enhance it to a dedicated GPON or carrier Ethernet network based on whether it's what the customer needs, whether it's business or a home office or something. So that is, we see an upsurge in people using their fixed wireless spectrum to do this. When you have business customers to serve, These can be small offices, medium enterprises, large enterprises. You could give them differentiated products. For small offices and home offices, you could actually use GPON to give a business broadband connection. GPON technology has come a long way, and I'll talk about that on the next couple of slides. And as long as you can give bandwidth reliably, the small offices should accept this. Also, naturally, where the small offices and home offices are located, you may have your GPON network reaching them rather than the network you design for businesses. For small and medium businesses, they can be served by carrier Ethernet. This could be a simple form of carrier Ethernet where you use Q&Q. The larger enterprises need deterministic private line type services, private line type, but on a packet network. And so they can be served with MPLS-TP, for example, which is a good technology to give, on a packet technology to give SLAs and QoS guarantees. Some customers may demand OTN, especially if their bandwidth requirements are 10 gig and above. So 1 to 10 gig MPLS-TP is a good technology. 10 gig and above, OTN is probably the preferred technology. So large enterprises will get served by this. Often there are small, warehouses or a branch office, a remote office where your fiber doesn't reach. So SD-WAN is a technology that you could use to complement your network just to reach these remote offices. But if you have fiber reach, the best way is to provide a dedicated circuit based on MPLS-TP. But if the rates, you have fiber reach, but the rates are more like 100 meg, then you could consider some other technology like carrier Ethernet. And SD-WAN, I think, is useful only to connect remote offices, especially if you are a wholesale operator owning the fiber infrastructure. SD-WAN has a limited role. I said GPON is improving. So if you're doing a new GPON network, a Greenfield GPON network, you could actually build a protected network that's protected all the way to the customer prem. So I call the distribution level network as the network from the splitter to the ONT, and the feeder network from the OLT to your last splitter. So GPON has a new type of protection. It has been there in the standards for a while, but hardly used, but now getting dusted up and put to good use. Type C protection, where you could install ONTs with 2 ports, a special kind of ONT, of course, and that's why this is suitable only for Greenfield. And then you have 2 separate paths to even 2 separate OLTs in the backend. So this makes the reliability of this network on par with most business networks. If you have a brownfield network, then you probably only have a single strand of fiber going into the home, and as such, a dual port ONT, a Type C ONT is not very suitable. In this case, you could do Type B protection, so you could have protected bandwidth up to the splitter, and then from there it's unprotected. This is most cases not a problem because the last segment of the network is quite short. It could even be from the street just into the building. And this can be a good way to add resiliency without visiting the customer home and all that, which is quite onerous. And it gives you, most of your network, the most vulnerable part of your network is protected. This can be a good way to enhance the reliability of the home broadband connections as homes are morphing into offices. This is protection from the OLT, but you also need to protect between the OLT and the internet gateway, which you can do as well with the new technology called Open ERPS. So let's say traffic is going through the bottom internet gateway. If there is a fiber cut, then traffic can go through the top internet gateway. This does not require any changes in the internet gateways or anywhere else. Our OLTs can be configured to do this Open ERPS protection. So that's the advantage, that in 50 milliseconds, you can get switching on the back end, which is completely independent of the IP MPLS network. There are no interop issues. Again, this is something which we have extensively deployed with our customers. The last customer segment would be large enterprises. These are web scale companies, Facebook, Google's, Amazon's of the world. They need high capacity to their data centers. And often they need securities or encrypted connections. They may need wavelength services because the capacity needs here are 100 gig plus. So, and given that they buy so much of the bandwidth, they do demand the lowest cost per bit. The large enterprises, previously I talked about serving, so large enterprises, this is the segment which demands wavelength services. They demand 100 gig services. Many of them are not content with 100 gig, especially in metros, and they ask for 400 gig connections. So this is really the ticket consumers of bandwidth, because pretty much all of our bandwidth needs end up in one of these big places. So they need to have an internet connection that can serve all their customers, namely us. Data center interconnect is one of the best growing segments. This accounted for over half of the WDM spend. This will account for half of the WDM spend by 2025. You would think we have enough cables under sea, but most of the emerging markets don't think so. So there are investments in new subsea cables in many emerging markets. Africa in particular is making multiple investments in subsea cables. And this is not only driving demand for undersea bandwidth, but also driving building up terrestrial networks, because this undersea bandwidth has to be distributed, on land. So we are seeing a lot of networking, terrestrial networking, also driven by undersea. And if you look at this chart a little bit closely, you will see metro is the fastest growing segment. There's enough capacity long haul. Also, if you build long haul for 80 wavelengths, you now have at least 8 terabits or even 16 terabits, 200 gig per lambda on the long haul. So metro is where the next action is for large enterprises. Previously, I talked about, say, even GPON technology for small cell backhaul for small enterprises, packet transport technology for medium to large enterprises, PTN. But when it comes to large enterprises, it's not a very good idea to serve them with packet-based technologies. So let's take this simple example. Let's say you have 3 customers who each need a 10 gig. So the first customer is off to the left on that screen. Then if they each need 10 gig and you build some kind of a packet network, say IP MPLS based or even MPLS TP based, and you need protected bandwidth, you need to build a 30 gig network. You can just serve 3 customers at 10 gig each, and this is 30 gig rings. Each of your packet boxes, your routers or MPLS TP transport equipment needs to have 60 gig worth of interfaces. This is not a good way to build networks for these kind of per customer capacities. The model on the right is much better. Your customers connect on 10 gig to an OTN network. You run the OTN ring at 100 gig, and now you have even more capacity. So instead of a 30 gig network, you have a 100 gig network. You have more than 3 times the capacity, and you will find that it is cheaper than building a 30 gig IP MPLS network. So because you have to handle packet traffic, you shouldn't be thinking of building your transport network based on packet technology, certainly not on IP MPLS technology. You should build a transport network, and for high bandwidth rates, OTN is the best technology. The reason this is lower cost is routers, ports on routers are very expensive. You don't, and most of the ports in this router is getting burned just to get traffic from the other 2 routers passed through. So it's not really doing any routing. It's just passing through traffic from other routers. So by avoiding that pass-through traffic and keeping it at the lower layer, a low-cost layer like OTN, this achieves much better performance at far lower cost. And of course, other things, it's not only CapEx, but power consumption is lower as well. Today, there is a greater focus on security. There is, so customers who are buying 100 gig want encrypted 100 gig. So we can encrypt in 2 ways. You can encrypt the ODU flex containers. So for example, the customer's taking 10 gig of bandwidth, you just encrypt the ODU flex carrying the 10 gig, or you could encrypt the entire 100 gig, right? The bulk encryption. So both kinds are suitable. And different customers will demand different types of encryption. But we are seeing an upsurge in requirement of encrypted connections, especially between data centers. And in order to address this, we not only put encryption on our boxes, but we also built very large cross connects, scaling up to 48 terabits. And I'll talk about that a little later. So the large enterprises need high capacity connections. They also need multi-terabit OTN switching, and they need encryption. So they need all three. And so OTN or Lambda services, high capacity OTN cross connects, and encryption. I talked about OTN services. Often when the rate touches 100 gig or more, you need to deliver services on wavelengths. It's often called a Lambda service. You may already have a WDM network, which is carrying, for example, a lot of 10 gig traffic. So most customers have some 80 wavelength 10 gig WDM network. That may be from some existing provider, some provider who may no longer exist, or you may want to have alternatives. So we have, I would say, perfected alien wavelength technology, where we can launch 100 and 200 gig waves onto existing 10 gig WDM networks, which is not ours, and we can launch these waves without any guard band. So that means if you had 50 gigahertz channels carrying 10 gig wavelengths, we could in a 50 gigahertz channel between two other 10 gig wavelengths insert a 100 gig or a 200 gig service. And we have done this maybe 15 networks in Africa alone, worldwide, or 20 odd, maybe 20, 25 networks. And I'm glad to say, in every case, been able to add over practically every third party WDM network alien wavelength services at 100 gig and also at 200 gig. So you could put your existing network assets to good use. You just need to have incremental capex just on the ends for the 10 gig and 100 gig, for the 100 gig and 200 gig transponders or muxponders. You just feed the output of those transponders or muxponders into your optical mux, your existing optical mux in your existing WDM network. So if I can summarize, the three customer segments are mobile operators, where the upcoming requirement is for small cell backhaul and 5G Fronthaul. With more and more fiber going in, even the 2G, 3G traffic, which may have been carried on microwave, will now be carried on the fiber network you're building for 4G and 5G. So you must ensure your fiber network is capable of circuit emulation, being able to carry the 2G, 3G traffic. So the backhaul network is necessarily shared and has to serve all these technologies. And you also need network slicing, because a slice to serve enhanced mobile broadband or machine-to-machine communication or ultra-low latency services will go across the transport network. So you need to be able to rapidly provision network slices. Coming to the retail broadband segment, everyone wants a fixed wireless connection at home. Everyone wants a fixed broadband connection at home. They'll take it if you can give them fiber. If not, wireless is a good way to start and get them hooked and then get fiber to them. This is what your retail broadband customers will be doing if you're a wholesale provider, and you need to serve them with, or you can also get into this game. We have seen actually some of our customers who are wholesale providers getting into fiber to the home. So they don't necessarily want to compete with their customers, but they build a network for their customers. And so they let their retail customers they let their ISP customers own the customer, but they build a network and offer the network as a service to their retail, to their ISP customers. So that's also becoming popular. That's a good business segment for wholesale providers. You need to differentiate the broadband offering for enterprises and homes as well with protection. And protection is upcoming for all sorts of GPON networks, type B, type C. Final segment for large enterprises. Oops, I flipped the slide. Sorry. For large enterprises, OTN is the right technology for 10 to 100 gig of bandwidth, and beyond 100 gig wavelength services. This is also used for wavelength services are probably what you will use between data centers for data center interconnects. This segment of the market also tends to demand encrypted services, especially encrypting a whole 100 gig. And alien wavelengths is a good technology also, so that you're not tied into buying equipment from your existing WDM provider. The last segment, I'll talk about products, so another 5 minutes. We have two product lines. The Access Edge products, which we call the 1400 series, which can be used to build all forms of access. So LTE-based access for fixed wireless, which is upgradable to 5G, GPON, XGS-based access. XGS-PON, I said, is getting popular now. Of course, MPLS TP or carrier Ethernet, you can do Q&Q or MPLS TP, whatever your customers prefer. And if you have legacy stuff, we also support SDH or OTN on the same box. So everything is supported on one box, which we call an ultra-converged access product. It's been welcomed by our customers. It's got rave reviews by leading publications as well. On the aggregation segment, we have the 1602, which is a micro OTN product. This product is actually capable of 1.2 terabits of transport capacity. So that means you can do two 600 gig interfaces and drop all of that. So it's like really a 2.4 terabit box here in just 2U. We support single fiber. That's important where there's no fiber at all. 600 gig per wavelength. And this is a 400 gig cross connect also without any fabric. Two cards act as a 400 gig cross connect. So there are two, I would say, canonical configurations. One is you put 200 gig in each slot, 100 gig on the line side, 100 gig worth of drops. And it's just a 400 gig OTN cross connect. That's one application we see. Another one is just as a 1.2 terabit transport. That means 2 into 600 gig with all of that being dropped as 100 gigs or a mixture of 110 gigs. So it's a very versatile micro OTN product. Beyond that, if you need very large capacity cross connects, we have a platform which is built on a disaggregated architecture where we have a core switch that scales to 48 terabits, and then the interfaces are on leaves. The leaf itself is a 900 gig PTN or an 800 gig OTN box. We have support 600 gig line rates, which is more or less table stakes today. So this is what's coming up for the core of your network. We are proud of this architecture. We embarked on this 2 or 3 years ago. Now that we are rolling out the product, we're glad to see very sort of largest service providers in the world. I think even AT&T a few months ago said they would like to explore distributed architecture that we have already been working on. So it's very scalable. You can't read this figure, but you can start with less than a terabit and grow up to even 48 terabits. This figure shows like 16 or 32, but you can grow further by having different leaves. So just to summarize, so before I hand it back to Melanie, so there's a huge surge in data traffic, 250% growth by 2025. COVID has actually accelerated a lot of that. There's surge in data traffic from homes, from mobiles. There's acceleration of IoT deployments, data center interconnections. So it's a good time to be a wholesale provider. See, in COVID, a lot of business segments are suffering. If you're in the transportation industry, I don't mean telecom transport, but say regular transport, then it's not a good time. Airplanes are struggling, hospitality industry is struggling, hotels are struggling. But telecom is one of the brightest segments where I think all telecom service providers are doing well, and so hopefully we as an equipment provider will do well too. The three segments are mobile, where 5G is what's upcoming. You will need to do a lot of small cell backhaul, fronthaul for 5G. And since 4G and 5G growth will require fiber at every cell tower, you will use the same fiber to serve 2G and 3G traffic, which means you need integrated backhaul as well. Broadband growth, I already spoke about it quite a bit. Protection in GPON, keep in mind, is something that's coming up. And even you could use GPON to backhaul small cell traffic. I did talk about that. So that's also upcoming. Large enterprises need OTN, so you need to shift strategy, not use packet networks to serve large enterprises. Beyond 100 gig, they would also need be served by wavelengths. Finally, keep in mind that we do offer an end-to-end portfolio that can serve all the needs of wholesale operators, access, edge, core, based on XGS PON at the lowest capacities, to packet transport, to OTN, and even wavelengths. So thank you for your time. I'll now hand this back to Melanie for questions. Thank you.
Thank you, Dr. Kumar. That was fascinating. Thank you so much for presenting all that insight. As you mentioned, we do now have a few questions from the audience. And to start with those, you mentioned about providing layer 1 services to large enterprises. How do you decide which option to deploy? What's the decision-making process?
So primarily, of course, it depends on what your customer wants. Your customer may already have a preference and say, I need a packet-based service or an OTN-based service. But typically what happens is up to a gigabit or so, you provide a packet transport-based service. 1 to 10 gigabit, OTN is more suitable. Anyway, OTN starts at 1 gig. The ODU containers start at 1 gig. So multiples of 1 gig can be provided with OTN technology. Even up to 100 gig is well suited with OTN. And beyond 100 gig, you do a wavelength service. So that's how.
Okay. And how do we decide which GPON protection to use, Type B or Type C?
If you are using your existing fiber plant, which means you have no option to lay fiber to the home again, then you actually just have to use Type B, because there's only one fiber to the home. You can only have a GPON box and ONT with a single port. And so Type B is your only option for a brownfield scenario. But if you're building out a new GPON network, maybe it's a new building coming up, a new apartment complex or an office building, mostly it will be apartment complex for GPON, then you have an option to deploy a 2-port, a Type C ONT, which will have 2 fiber ports. Then you'll have to run 2 fibers up to each home, maybe from different sides of the road or something. So Type C is certainly an option for you. And if a customer doesn't want to pay for Type C, even in that scenario, you could do Type B. So Type B is the only option for brownfield. Type C is an option if you're building a greenfield network.
Okay, and another question now from the audience. We have both TDD and FDD mobile operators using our network. Do we use SYNC-E or PTP or both for synchronization?
Okay. So FDD requires only frequency synchronization. So SYNC-E alone is good enough for FDD. But TDD, the synchronization requirements are much more stringent. So you'll need to have time synchronization, because all the base stations have to be synchronous in time. Otherwise, there will be interference. Actually, the base stations of all operators have to be synchronous in time. But so you have no option but to use something like PTP. SYNC-E alone will not suffice. And since 5G, which is coming up, is mostly TDD based. So you could say that, I'll give a longer answer. Since FDD is mostly meant for legacy bands, so up to 2.1 gigahertz, the bands you used to use for 2G and 3G, when they transition to 4G, become FDD. But all new bands are TDD, so beyond 2.1. And 5G will be mostly TDD because it will be deployed in the upper bands. So coming up for TDD will be the dominant technology, and you do need PTP-based synchronization for TDD networks.
Okay, I'm sure that answers it. How does Tejas carry 100 gig transmit and receive signal on a single fiber? And can it be done for long distance, or is it applicable only for metro?
So for single fiber technology, the best option, the reason for single fiber first is good to understand. If you're putting in a lot of fiber, why not put in fiber that you have one for each direction? But what happens is operators, when fiber is very scarce and there are many operators end up leasing just one fiber. They used to lease a pair, but it's now become so expensive that now some operators lease one strand of fiber. Sometimes they also swap. So operator A has a pair of fiber on one route, the other operator has a pair on another route. So they decided to swap one fiber each. So when they do that, they need to use a single fiber strand. So you can, so instead of doing 80 wavelengths each direction, you could do 40 wavelengths in one direction and 40 in the other. And this is the best, most reliable way of carrying traffic on a single fiber. Just use half the wavelengths in each direction. And this can be done for long distance, so there are no distance limitations. There's a small additional loss due to the fact that you're combining both, but that's quite small. And so you could pretty much achieve the same link lengths that you would with a pair of fibers with a single fiber.
Okay, and another question from our audience now. Do you expect to have 400G packet client interface, or 400G is only for NNI?
Okay, so that depends on Cisco, because if they make router interfaces at 400 gig, then we would necessarily have to have a 400 gig packet client. But today, 400 gig is only an NNI, and the maximum client interface we see is only 100 gig. It's not yet even 200 gig. That can change over time, but I don't see that changing very quickly, because it's not incremental efficiency for a router to put out one 400 gig as opposed to 4 100 gigs is practically negligible. So I think it'll be some time before we see 400 gig client interfaces. It would only be packet. It would only be NNI.
Okay, thank you. And do you have a private LTE offering, and can it work in the Philippines?
Yes, we do have an LTE offering in the access network, access technologies we offer. I didn't talk much about it today, being a wholesale seminar, and it works in all TDD bands from 1.8 gigahertz to 3.5 gigahertz. So that would be band 38, 39, 40, 41, 42, even 43. So if you have spectrum in any of these bands, please contact us and we'd be happy to work with you. And yes, we can support a private LTE network as long as you have spectrum in one of these bands.
Okay, that brings us nicely on to the next question, actually. One of our audience members has said, I'm a wholesale operator, but do not have any licensed spectrum. How can I offer FWA service? Okay,
if you don't have licensed spectrum, then you could try offering fixed wireless service in unlicensed bands. There are two unlicensed bands, 2.4 gigahertz and 5.6 gigahertz. 5 to 6 gigahertz. It's typically called the 5 gigahertz band. I think all of us are familiar. Our home Wi-Fi always puts out Wi-Fi, access point A and access point 5G. And you think it's 5G is like something to do with the 5G mobile network. No, it's just the 5 gigahertz unlicensed band. The 5 gigahertz unlicensed band is becoming more popular for offering fixed wireless access, but you could do both. So you could try unlicensed spectrum, a very highly directional antenna, and a focused connection we can offer. You're subject to interference, but that's the price you pay for not having spectrum.
Okay, and can you explain next how you get 48 terabytes per second?
Okay, sure. So currently we have 1 terabit drop boxes, what we call leaves. Okay, so I think we can connect up to 24 leaves to the core network. I might get some of the numbers wrong, but broadly that's what it is. So you get 24 terabits if you have only 1 terabit leaves to connect to the core switch. But if you can come up with a 2 terabit leaf, and that's in our plan, once this technology takes off, then you could do 24 of those boxes and come up with a 48 terabit box, 48 terabit cross connect. Another thing I want to point out is that this is not just a cross connect, OTN, it's also a packet switch. So you could actually get either packet or OTN. Our first release is based on making it an OTN cross connect, but in future releases we'll support packet traffic as well.
Okay, wonderful. Dr. Kumar, I think that, excuse me, I think that concludes our audience questions for the time being. Thank you very much for joining us today. The session will be available on the BrightTalk and Capacity websites. Thank you very much, Dr. Kumar. Have a great day.
Thank you, Melanie, and I also thank the audience for their time today. Have a good day.